In this project, we're gonna explain about the Chernobyl nuclear reactor disaster and two other real situations that can be represented by exponential growth and decay functions. The exponential basic graph, the reference point is 0, 1. Its domain is all real numbers and the range is greater than 0.
In August 26, 1986, operators of Unit 4 of Chernobyl's nuclear plant were running a test on an electric control system. The plant had many unstable failures that had not been treated. The tragedy happened because of those engineering deficiencies in the reactor and decisions by operators that made the situation worse, operating in an improper manner. Somehow, the safety systems were not working, allowing a huge power surge to happen, resulting in the nuclear fuel to overheat. When it overheated, many steam explosions erupted, spreading through the reactor, causing many other reactions to occur, liberating many gases and substances that are dangerous for the general environment, damaging it all, erasing away the whole Unit 4 reactor.
The reactions mainly created massive fires that some were set off by firefighters. Many hours after this event, materials inside the building reacted with combustible gases, creating even more fires, reactions lasting 10 days. Many measures were made to stop the expanding damages, where toxic gases and fumes went up into the air to be around all Chernobyl. Rescue helicopters were sent many times a day to dump neutron-absorbing compounds and fire control materials into the crater created by the initial destruction of the reactor. Other reactors units helped to stop the reactor structure from fire and to originate more damage by cooling it down with liquid nitrogen through pipelines. The aftermath of the event included the general contamination of Chernobyl, mainly caused by the release of radioactive materials that enormously affected the lifestyle of people living in that area, including their health. One material that was thrown into the air was cesium-137, which is hardly dangerous. It stated that the least amount of that product allowed in the environment for human inhabitation is 100 kilograms. The release of it at the specific day was of 1,000 kilograms, making it an oversaturated area. In the present, we are able to see the current contamination that the explosion that occurred 31 years ago still affects people in its surroundings. It is still an historical event because of being most serious accident and having the most negative outcomes in nuclear industry. 5 million people still live in these areas to date, affected by the constantly contaminated food and resources around them by the cloud formed around it because of the reactor's accident. The amount of radiation today is uncertain, but it has damaged many economic stability, quality of healthcare, and life expectancy of the population.
One of the first measures taken to control the fire and the radioactive materials released was the dumping of neutron-absorbing compounds into the initial area of destruction. The total amount of materials dumped into the reactor was approximately 5,000 tons, including boron, compounds lead, sand, clay, dolomite, and sodium phosphate, and polymer liquids were in the mix of passengers sent in helicopters. In the table below, it can be seen the exponential growth of the necessity to bring even more materials per day. Each 24 hours, the amount grew more times than the last unit sent, creating a growth that radically went up in 5 days. Connecting the points in the table gives a better understanding of it growing exponentially.
It was informed that a toxic substance was released into the air as a result of the explosion, cesium-137. The total amount of the substance in Chernobyl from that date was 1,000 kilograms. The condition has been going in decay, but extremely slowly, with Chernobyl with cesium-137 remaining to date in this atmosphere. The following function gives the amount of remaining kilograms of the substance in a certain year after the event, which is represented by X with a number of years after 1986. Scientists have expressed that if even 100 kilograms of cesium-137 remain in the Chernobyl area, this is not an inevitable for any human being.